Today we have count number of bad pairs. It says you are giving a zero-indexed array nums. A pair of indexes I and j is a bad pair if I is smaller than j, and basically the difference between the indexes is not equal to the differences between their values. So j minus I not equal to nums of j minus nums of I. So basically, if we have 1 and 4, so the indexes of 1 and 4 has to be not equal to their actual values difference. That means it's a bad pair. It wants to know the number of bad pairs in nums, right? The total number of bad pairs in nums. One way you could approach this, if you didn't look at the constraints, is actually just doing an n-squared solution where you'd loop over every I and every j and calculate the number of bad pairs. But it probably wouldn't work. I didn't try it, but it probably wouldn't, like, it would give you TLE, definitely time limit exceeded. However, these questions sometimes, there's a way to reformat the input. This is like a technique you could use sometimes where you reformat the input into something more convenient to be able to solve the problem. So basically it says here j minus I is not equal to nums of j minus nums of I. So basically what this means is j minus nums of j is equal I minus nums of I if you shuffle them around. So basically if the I is here and you bring it the other side, and then if the j is there and then you bring it out the other side, it's going to give you j minus nums of j has to not to be equal I minus nums of I. That's this is a good pair, basically. It's a bad pair if they're not equal. So basically what the solution was for me was, let's get the count. There's an equation to get the count of all the pairs in an array, right? It's like it's n, which is the length of array, multiplied by n minus 1 over divided by 2. That's going to give you the number of pairs in the whole array, right? So the solution for me was get all the pairs and then find a way to get the good pairs and then subtract them from each other. And that way you get the bad pairs, basically. So these kind of solutions will come by experience. They're just, it is what it is. I have here a scene hash map, which basically dictates that if I see, so what I'm going to do is I'm going to transform the array into this equation, right? So for every value, I'm going to change it into I minus nums of I, basically. I'm going to literally reformat the array. I don't need the numbers. And then the theory is going to be, if I find that number more than one time, right, then they form a pair together. So basically, if I see, in my case, let's say we did this transformation, right? And then remembering that if I find that number several times, that's a good pair, right? And I need to get rid of them, basically. So nums of I is equal to I minus nums of I for every single index. And then I'm adding scene. This is just literally a counter. I don't know why I named it scene. I actually should rename it to counter or something, basically. Yeah, so counter here, counter there. So basically, if I see this cut, let's say I saw the number 5 like 4 times, right? So I saw it 4 times. What that means is there is a mini array of 4 values that I need to remove all the pairs together. So basically, this array you can form many pairs of this array. You can form many pairs. So imagine you have an array of 5s, right? Which is like there's 4 5s in the array. How many pairs you can do, right? So it's basically, if there's 4 5s, that means 4 times 3 divided by 2, right? So I need to get rid of all the pairs from the same numbers together. Like, it's like every counter here holds a mini array, basically, in a way, where you want to remove the pairs occurrence of that number. So that's why I keep track of the counter. And then I just calculate the total number of pairs in the whole array, right? And then I loop over the hash map. If I find out that there is a counter greater than 1, so basically 1 meaning I only saw that number 1 time, so that number paired with anything else is going to be a bad pair because I've never seen it before. Otherwise, sometimes there's a couple of numbers that appear more than 1 time. In that case, I'm going to remove their pair count, right? Which is the count multiplied by count minus 1 divided by 2. Removing that pair count from the total values, right, will give you the number of bad pairs, essentially. Yeah, because these are good pairs. I'm removing the good pairs from the total, right? and then returning res. So yeah, the time complexity is O of n here. I'm not. I hope I explained it properly. Thank you guys for watching, and see you in the next one.